So what is turmeric? It is a compound derived from the rhizomes of the curcuma-longa plant and a member of the ginger family. So if you've ever seen ginger before, it's a little root vegetable. Turmeric looks almost identical, only when you break it open, instead of being kind of white to off-white in color, it's extremely orange on the inside. It's native to Southeast Asia and the Indian subcontinent, where it has been cultivated for thousands of years. A staple in culinary traditions and a critical component of Ayurvedic medicine due to its health-promoting properties. If you've ever had curry before, you've most likely had turmeric. Curcumin, which is sometimes used interchangeably with turmeric, is one of the main active ingredients in turmeric. There are numerous amounts of plant-based chemicals in turmeric. Curcumin's the one that's probably the most well-studied for its medicinal benefits. It's a polyphenol with potent anti-inflammatory and antioxidant effects. Okay, so different functions of turmeric. It's used in cuisine, in cooking world. It's known for its warm, bitter taste as well as mustardy smell. It's a key ingredient in curries and is used for coloring and flavoring in many Asian dishes. For medicinal use, turmeric has been used to treat conditions ranging from colds, inflammation. Its application in Ayurveda and traditional Chinese medicine spans the treatment of pain, inflammation, gastrointestinal issues, and now we're seeing turmeric being studied for so much more, which is what we're going to be talking about today as well. Okay, so if we break down some of the broad categories of the health benefits of what turmeric can help support. So number one, it's been researched and studied for its anti-inflammatory properties. As you see here, research suggests that the curcumin in turmeric suppresses molecules known to play major roles in the inflammation cascade. Molecules like cyclooxygenase and MAP kinase have been studied as it relates to curcumin. We know it has antioxidant effects. We also know that studies show that curcumin, its effects on inflammation and oxidative stress may protect against common conditions like Alzheimer's and dementia, as well as cancers. We know that it has cognitive and mental health impacts as well. There's emerging evidence that shows that turmeric may boost brain-derived neurotropic factor, offering potential protection against dementia and depression. So let's dive into some of these mechanisms. Now, there's a lot of research, and what I've done is I've pulled for you some research and some diagrams to help you better understand some of these mechanisms that turmeric can provide. So if we look here again, turmeric is the source of these compounds called curcuminoids. And so if we look at arthritis, we know that it has anti-inflammatory activities. It regulates these enzymes called kinases, which play a major role in inflammation. And there's a number of research studies that have shown that turmeric, when you put it up against drugs like ibuprofen and acetaminophen, Tylenol, that it actually works as well and in some ways works better. And we'll talk about that here shortly. We know that with neurological disorders, it has an anti-inflammatory activity that regulates oxidative stress, reducing neuroinflammation, maintaining mitochondrial function, but also regulating the production of the neurotransmitters dopamine and serotonin. Remember, a lot of the medicines used in allopathic medicine target the preservation of dopamine and serotonin. And so again, curcuminoids have been shown to regulate these neurochemical productions. We know it plays a role in cardiovascular disorders. Again, you'll see this term a lot: regulation of oxidative stress and anti-inflammatory activity. But we also know that curcuminoids can regulate the apoptosis, which is just a fancy way of saying controls how cells kill themselves to make new cells. And so apoptosis is also an important regulator of cancer and cancer processes. Metabolic disorders, again, anti-inflammatory activity. We see these repeating regulating kinases. And as far as diabetes, helps to regulate the release of insulin, helps regulate glucose levels, and acts as an antioxidant and anti-inflammatory. So a lot of different tissues that can be impacted by curcuminoids. Let's look at this next one. This is interesting because beyond the antioxidant and the anti-inflammatory effects, we know that curcumin also has an impact on different types of bacteria. And so one of the ways that it impacts is through what's called biofilm disruption. Biofilm disruption. So if you look here, let's zoom in on this image, make it a little bigger here. You can see here these little yellow items. These represent bacteria. When bacteria get together, they form colonies. When they're in colonies, they produce this structure around the colony. It's like the moat and the gate around the castle wall. It's called a biofilm. It's what bacteria produce, again, as an agent of protection. And so when biofilms are present, it makes it much more challenging and difficult for antibiotics to work. And this is one of the mechanisms behind antibiotic resistance. It's when colonies of bacteria and other microorganisms form these biofilms to protect themselves from your immune system, but also from any kind of medications that you might take. Well, what we know about curcumin is that it has the capacity to break down biofilm, and that's what you're seeing over here in this last section. It is disrupting that biofilm, thus breaking those bacteria out, making them more susceptible to your immune system or to any kind of medications that you might be taking. Now that we know that it can bust out and break down biofilms, there are other antimicrobial impacts of curcumin and turmeric that we want to discuss. One is it's been researched and studied that it can aid in inhibition of bacterial cell division. So it slows down their ability to make new bacteria. We know it can inhibit quorum sensing dependent virulence. Quorum sensing is the way that these types of microorganisms communicate with each other about growth. We know it inhibits different species of gram-negative and gram-positive bacterial growth. And I see this a lot where you get these gram-negative, especially with these gram-negative bacteria that colonize people's GI tracts. And these bacteria can be linked to liver damage and to joint pain and rheumatoid arthritis and other autoimmune forms of illness. These are bacteria like Pseudomonas and Klebsiella. Well, again, we know curcumin can impact their ability to grow. We know it can inhibit the bacterial SOS response, and we also know that it can disrupt bacterial cell walls and cell membranes. So it can break through those cell walls and cell membranes, again, lysing the bacteria, destroying it. So a lot of different capacity for curcuminoids to impact microbes. And this is one of the reasons why historically in Ayurvedic medicine, curcumin has been used and turmeric has been used as an agent in intestinal inflammatory diseases, in gastric inflammation and intestinal inflammation. Now we get to some of its anti-cancer effects. So you can see here, curcumin has an apoptotic effect on cancer cells. What does that mean? It means programmed cell death. So it basically instructs cancer cells to kill themselves. That's what apoptosis is. And we know that this herb has that potential. We also know that it blocks angiogenesis. What does that mean? Angiogenesis is the formation of new blood vessels. So when a tumor forms, it likes to grow blood vessels. That's what you're seeing here. It likes to grow new blood vessels so that it can spread and those cells can spread and grow out. And so, again, this is blocking that process, producing or reducing, rather, tumor cell invasion. We also know that it blocks tumor cell metastasis, so the way tumor cells can move to other parts of the body and potentially cause tumors to form and create issues. We also know that it can inhibit a number of different metastatic or pro-metastatic factors. So these are chemicals that help cancer cells potentiate and grow. And we know that this, again, that curcuminoids can affect and impact those metastatic factors. So a lot of research now coming out on the impact of turmeric on cancer, especially studies that are being done in animals, studies that are being done, what are called in vitro studies, as well as human studies now coming out. If we look at the research on this, we'll call it superfood, if you will, this is a review paper looking at, over time, the amount of research that's been done on turmeric and curcumin. And so what you can see here, not a lot of research. We go back to 1986 and kind of all the way up to 2006. There's really not a ton of research being done. But all of a sudden, you see here around 2007, there's this giant influx and increase in research. And so you can see how this map is color-coded here. The research being conducted on curcumin in metabolic disease, as well as non-alcoholic. This kind of dark orange represents non-alcoholic fatty liver disease. That's this segment here. And then you can also see musculoskeletal disease. That's this gray segment, and GI tract disorders here, as well as cancer, which you can see here in green. And then we also have neuropsychiatric disorders in yellow. So again, a lot of new research is coming out on curcumin in the last 20 years or so. We're seeing more trials, and these are including human trials. And so those are some of the things that I want to discuss and kind of point out today as well. This is not intended to be a comprehensive review of every trial or every study that's been done, but I want to point out some of these. So you can see this is curcumin supplementation in human disease. This is a review of different clinical trials that have been done in humans. So you can see here they did a scoping review conducted to assess human clinical trials reporting oral curcumin and other oral supplemental curcumin effects on disease outcomes. You see most of these associated on obesity and metabolic disorders, and then coming in musculoskeletal disorders where inflammation is a key driver, and beneficial effects on clinical outcomes and/or biomarkers were reported for most situations. And a lot of these studies are double-blind, randomized, placebo-controlled trials, right? What they call the gold standard of medical scientific evidence.